Lesson: Ultrasound. Explain the principles behind the generation of ultrasound waves for diagnosis in medicine. Piezoelectric transducers produce ultrasound. Electrodes may be formed on opposite sides of the crystal, by depositing silver on its surfaces. When a potential difference is applied between the electrodes, depending on the direction of the electric field, the crystal will become slightly thinner or slightly thicker. An alternating voltage applied across the electrodes causes the crystal to vibrate, with a frequency equal to that of the applied voltage. If the frequency of the applied voltage is equal to the natural frequency of vibration of the crystal, resonance will occur, and the amplitude of vibration will be a maximum. These oscillations will give rise to ultrasound waves in any medium surrounding the crystal. Explain the principles of the detection of ultrasound waves for medical diagnosis. Ultrasound wave is a pressure wave. Reflected ultrasound pulses incident on quartz crystal. Crystal oscillates following pressure variation of the pulses. Oscillating crystal generates EMF across two surfaces, electrodes, of the crystal. Explain the principles behind the use of ultrasound to obtain diagnostic information about structures within the body. Ultrasound pulses are transmitted into the body. Coupling medium on skin is used to reduce reflection at skin. Reflected pulses from internal boundaries are then detected using same transmitter. Receiver processes those signals and displayed. Intensity of the reflected pulses gives information about the nature of the boundary. Time delay gives information about depth or distance of the boundary from the transducer. Define specific acoustic impedance of a medium. Specific acoustic impedance is defined as the product of the density of the medium and the speed of the wave in the medium. Explain why acoustic impedance is important when considering reflection of ultrasound at the boundary between two media. Difference in acoustic impedance determines the fraction of incident intensity that is reflected back at the boundary between two media. Suggest why the ultrasound from the transducer is pulsed. Transducer can be used as both transmitter and receiver. It receives signals during time intervals between transmitted pulses. Ultrasound signal needs to be pulsed in order to measure time between transmitted signal and received signal to get depth information. An ultrasound transmitter emits a pulse. Suggest why, when the signal from the pulse is processed, any signal received later at the detector is usually amplified more than that received at an earlier time. Later received reflected pulses have passed through greater thickness of the medium, hence subjected to greater attenuation than those reflected from boundaries near the skin. To allow for this, signals received later at the transducer are amplified more than those received earlier. Ultrasound frequencies, as high as 10 MHz, are used in medical diagnosis. State one advantage of the use of high-frequency ultrasound, rather than lower-frequency ultrasound. Smaller structures can be resolved. Ultrasound frequencies, as high as 10 MHz, are used in medical diagnosis. State and explain one advantage of the use of high-frequency ultrasound, rather than lower-frequency ultrasound. For higher frequency ultrasound, the wavelength will be shorter and there will be less diffraction around small features. That is, smaller structures can be resolved. The main advantage of ultrasound scanning, compared to X-ray diagnosis. Health risk to both the patient and to the operator is very much less. Ultrasound equipment is much more portable and is relatively simple to use.